At 9:47 in the morning, on a clear June day in 1944, a P-51 Mustang with the nose art Jerry lifted off from an airfield in England. Inside the cockpit, Lieutenant Thomas Fraser settled into his routine. Throttle forward, slight right rudder to counter the torque, a quick glance at the instruments. Oil pressure good. Coolant temperature rising into the green. The Packard-built Merlin engine in front of him pulled the fighter down the runway with a smooth, eager surge. He had done this many times. But this time, the sky over the channel looked different. This was June 6th. Allied ships filled the water below, a vast procession of vessels heading toward the French coast. Smoke on the horizon marked the beaches where troops were going ashore. Fraser and the rest of his squadron had a simple but critical assignment: keep enemy aircraft away from the invasion corridor and from the columns of bombers supporting the landings. The P-51B he flew was perfectly suited for this kind of mission. Long, slender wings designed for low drag. 4 heavy machine guns in the wings. Enough internal fuel, plus external tanks, to stay over France for hours and still get back to England. When the Mustang first appeared in numbers over Europe, pilots like Fraser felt as if someone had finally given them the tool they had needed all along. He climbed to altitude with his group, joined formation, and headed toward the continent. Radios crackled with brief messages. Call signs, altitudes, vectors from controllers. Below, the surface of the channel looked deceptively calm. Far ahead, thin layers of cloud stretched over northern France. For a while, everything went as planned. The squadron cruised above the bomber stream, weaving slightly to cover more sky, scanning for threats. Fraser kept one eye on the horizon and one on his instruments. The Merlin hummed steadily at cruise power. Then, somewhere over French countryside dotted with fields and hedgerows, one of the needles on his panel began to drift the wrong way. The engine note changed. Hardly at first, a roughness, a slight vibration. Then the oil pressure pointer trembled and sagged. Coolant temperature began to creep higher than it should. The Mustang's greatest advantage, its liquid-cooled power plant with tightly packaged radiators, could turn into its greatest vulnerability if that cooling system was compromised. Fraser tested the throttle, adjusted mixture, checked if the engine ran more smoothly at a different setting. It did not. The roughness increased. The gauges were no longer politely hinting at a problem. They were announcing it. He had 2 choices. Stay with the formation and risk the engine failing completely at high altitude, or break away and look for somewhere, anywhere, to put the aircraft down before it stopped responding. The second option carried its own dangers. The land below was still under German control. Every field, every road, every village could hold soldiers, patrols, or militia. He keyed his radio and reported his situation. Then he rolled away from the formation, eased the nose down, and started searching for a place to attempt a landing. From above, northern France looked almost peaceful. Patches of woodland, cultivated fields, small farmsteads, and winding lanes. No prepared runway within safe gliding distance. No friendly airfield. Only irregular open spaces, some sloping, some bounded by hedges and trees. The engine's condition gave him little time to be selective. He picked what looked like a relatively flat, long field, dropped the gear, set flaps, and committed. The approach was rough but controlled. The Merlin coughed and lost more power as he came in, but gravity did the rest. The Mustang's wheels touched grass, bounced once, then rolled. A cloud of dust and bits of vegetation sprayed outward. The aircraft shuddered but stayed upright. When it finally came to a halt, the propeller blades were intact. The wings were straight. The airframe seemed largely unharmed. Inside the cockpit, the engine now sounded more like a complaint than a song. Fraser ran through a quick shutdown, unfastened his belts, and climbed out. The field was quiet except for the ticking of cooling metal. The Mustang, his carefully maintained, much-trusted machine, sat there like a visiting creature dropped into the French countryside by mistake. He took one last look at it, then turned and began walking, trying to put distance between himself and what would surely attract attention sooner rather than later. Within a few hours, German patrols moving through the network of roads and villages in that region had spotted the downed fighter. The presence of a distinctive Allied aircraft sitting intact in an open field was not something local authorities would ignore. Soldiers arrived, secured the area, and searched the surrounding hedgerows and paths. Fraser, on foot and alone in unfamiliar terrain, was quickly located and taken into custody. His personal journey would continue along a different path, from cockpit to prisoner camp, which is another story. For the Mustang, However, the story was just beginning. The German Air Force maintained specialized recovery units whose sole purpose was to reach crash sites quickly, salvage usable components, and, when possible, recover entire aircraft. Allied pilots knew this, which is why they often made an effort to damage force-down machines from the air if they could. But on a day like June 6th, when thousands of aircraft were busy supporting the landings, a single Mustang in a French field did not immediately attract that kind of follow-up. The salvage team that arrived worked with a practiced efficiency. Their procedures had been refined after years of attending to wrecks scattered across Europe. Even in this rare case, where the airframe was largely intact, they followed a sequence. Fuel remaining in the tanks was drained to prevent accidental fire. The battery was disconnected. Sensitive equipment and documents, if any remained, were removed. The canopy was protected. Guards were posted to keep away curious locals and to ensure no roaming Allied aircraft tried to make a target of the grounded machine. Trucks and specialized trailers soon followed. By late evening, the Mustang was winched onto a flatbed and secured for transport. Under the camouflage netting and dust, it still looked like an American fighter, but its journey from now on would be entirely under German control. As the sun rose the next day, the train that carried it pulled out, heading east. Its destination was a place most frontline pilots had heard of but never visited, a remote test and evaluation center in northern Germany. There, in a complex of runways, hangars, and workshops surrounded by forests and fields, engineers and test pilots examined every new aircraft type Germany produced, and every enemy machine that could be coaxed back into the air. Captured bombers had gone there. So had fighters from Britain, the Soviet Union, and the United States. Each one had been repaired, repainted, and flown by pilots whose job was not to fight in combat, but to understand. The arrival of a nearly intact P-51 Mustang, especially in early June 1944, was therefore treated as a priority event. The air war over Europe had changed dramatically in the preceding months. Long-distance American raids that had once led to heavy bomber losses were now escorted almost all the way to their targets and back. This new escort, slender-winged and painted in Allied markings, seemed to be present everywhere. German fighter units had learned to respect it the hard way. From reports compiled by combat units, German intelligence analysts had a partial picture of what this aircraft could do. They knew it had an impressive range. They knew it held its own, and more, in engagements with Messerschmitts and Focke-Wulfs. They noted that bomber formations accompanied by these new escorts suffered fewer losses. But all of that knowledge was indirect. It came from watching the Mustang in action from a distance, or from quickly examining fragments after it had been brought down. Now, in the workshops of the test center, stood one specific machine, largely complete. Its internal workings could be examined at leisure. And soon, someone would sit inside it, start the engine, and find out how it behaved in the air. The man chosen for that task was not a frontline ace with a string of personal victories. He was something quite different. By mid-1944, Karl Werner had accumulated an experience that no fighter squadron leader could match. He had flown well over 100 different types of aircraft. As a teenager, he had started on gliders, learning the feel of lift and air currents without the distraction of an engine. When powered flying became possible for him in the 1930s, he immersed himself in it with the same disciplined curiosity. Trained as an engineer as well as a pilot, he tended to think about aircraft in terms of airflow, stress, fuel consumption, and control forces, not just as machines that pointed this way or that. When the conflict erupted, the Air Service soon realized that someone with his combination of technical understanding and flying skill was more valuable in a test center than in a combat unit. Instead of sending him to earn awards in the skies above the front lines, they sent him to the place where aircraft were born, evaluated, and sometimes quietly shelved. At the test facility, Karl's work fell into two broad categories. One was to assess new German designs. Fighters, bombers, trainers, prototypes that stretched existing technology and early versions of planned models all passed through his hands. He took notes on takeoff characteristics, climb rates, handling quirks, maintenance demands. The other category was more unusual: captured aircraft. Whenever an Allied machine arrived in flyable or repairable condition, it was assigned a temporary German code and handed to a team of mechanics. If they could get it into the air safely, Karl, or one of his colleagues, would climb into the unfamiliar cockpit and see what it could do. The variety was astonishing. He had strapped into sleek British fighters with elliptical wings, heavy American attack aircraft bristling with guns, agile Soviet designs suited to low-altitude work. He had flown twin-engine craft that felt underpowered and others that surprised him with their responsiveness. He often went up in machines for which there were no proper manuals, relying on engineering intuition to find essential controls and to guess safe limits. Despite the risks, his record remained remarkably clean. He had brought these strangers home again and again, adding their behavior to the growing library of knowledge the test center accumulated. When the Mustang arrived, his instructions were firm and unusually urgent. Have it ready for flight within 2 days, and then give a thorough report. Normally, captured aircraft took much longer to prepare. Mechanics would comb through every system, wary of hidden damage or sabotage. With this one, the timeline was compressed. That spoke volumes about how interested the high command had become in understanding this particular opponent. The technical personnel assigned to the Mustang worked almost without pause. They removed the engine, tracked down the issue that had forced Fraser to land, the cooling system leak that had quietly undermined the power plant mid-mission, and corrected it. They inspected the wings, control surfaces, and fuselage for stress or hidden cracks. Fuel lines and hydraulic systems were checked and, where necessary, refreshed. At the same time, painters gave the aircraft a new appearance. To reduce the risk of misunderstandings with ground defenses, captured machines at the test field received very visible markings. The undersides and tail were coated in bright color. Large crosses replaced the original insignia. A unique code was applied to the fuselage so that records could track which specific aircraft had been flown and what had been learned. On the morning chosen for the first flight, the Mustang no longer looked quite American at first glance. Yet its shape, its proportions, and its internal heart remained the same. Carl walked across the apron toward it, clipboard in hand, mind already working through a mental checklist based on fragments of intelligence and his own expectations. He began not in the cockpit, but with a methodical walk around the airframe. The first impression was one of clean design. The surfaces were smooth, with careful attention to minimizing protrusions. The wing profile was noticeably thin, even more so than on the German fighters he knew well. For an engineer's eye, this immediately suggested a focus on reducing drag and maintaining efficient airflow at higher speeds. He studied the joints and rivet lines. There was a deliberate effort to keep the skin as flush as possible, reducing turbulence. The tailplane and vertical fin looked conventional but well proportioned. Control surfaces appeared balanced and sturdy. Underneath, he paused at the radiator housing. The Mustang carried its coolant radiator and oil cooler in a belly scoop beneath the fuselage, a configuration distinct from the wing root installations he was used to seeing. He knew, from reports, that this scoop not only handled cooling but also, through careful shaping, generated a modest amount of useful thrust at speed by turning heated air into a kind of jet. Standing beside it, he could see how tightly the system was integrated into the fuselage lines. He walked along the leading edge of the wing, noting the position and angle of the guns. 4 weapon ports on each side gave the aircraft a dense forward field of fire. Ammunition access panels indicated straightforward reloading procedures. Everything suggested a design optimized for quick servicing between sorties. Moving to the cockpit, he climbed the ladder and eased himself into the seat. The first thing he noticed there was space. Compared to the snug fit in many German fighters, the Mustang's cockpit felt more open, with slightly more room to move and a canopy that provided a wide view forward and to the sides. It was not as unrestricted as the full bubble canopies that would appear on later variants, but it clearly prioritized situational awareness. The instrument panel, while crowded, followed a logical arrangement. Engine gauges grouped together. Flight instruments clustered in front of the pilot's main line of sight. Labels were in English, numbers and units different from those he used daily, yet the underlying logic matched that of any thoughtful designer. Once he translated miles per hour into a feel for speed and feet into a sense of altitude, he would have the same information any local pilot enjoyed. The main controls were where he expected them to be. Control stick centered, rudder pedals comfortably placed, throttle quadrant on the left, with propeller control and mixture levers nearby. Switches for weapon systems were clearly marked, and he made sure they were locked in a safe position. He traced fuel system selectors, flap controls, and the landing gear handle, committing their positions to memory. He tested the free play of the controls. The stick moved smoothly in pitch and roll. The rudder cables transmitted movement without slack. Ailerons and elevators responded crisply as ground crew outside confirmed their deflection. On his checklist, he had another category: ergonomics under stress. How easily could a pilot, in turbulence or under high load factors, reach essential levers? Could he change fuel tanks without taking his eyes off the sky for long? Did the layout guide the hand naturally to the right control? On that front, the Mustang scored well. Nothing about the cockpit felt like it would fight the pilot. When he had finished his inspection, Carl signaled to the ground crew to begin the start procedure. The Merlin engines start a word, then caught. Cylinders fired, exhaust stacks flickered, and the sound settled into a firm, complex note that was distinct from the deeper tone of German engines. It had a slightly higher pitch, a smoother character at idle. He watched the gauges as oil pressure built and temperatures slowly climbed into their normal range. He performed a brief engine run-up, cycling the propeller control, checking magnetos, listening for irregularities. Everything responded within expected limits. Taxiing the Mustang toward the runway presented no surprises. Steering via rudder and cautious braking was familiar enough from other foreign types he had flown. The visibility forward over the nose, while not perfect on the ground, was manageable with slighter turns. At the threshold, he paused for a last glance at his instrument panel. All readings lay where they should. Controls felt alive under his hands. He advanced the throttle smoothly, careful not to be abrupt with an engine known to reward finesse. The Mustang surged forward, gathering speed quickly. The tail lifted, the runway markings began to blur beneath the wheels, and with a gentle back pressure on the stick, the aircraft rose into the clear morning air. The moment the wheels left the concrete, Carl's focus narrowed to the interaction between his hands, the controls, and the aircraft's response. The climb out was steep, powered by an engine that clearly had reserves beyond what was strictly required for a gentle ascent. He retracted the gear, watched the lights confirm safe stowage, and allowed the Mustang to settle into a steady climb to a safe working altitude. At 5,000 feet, he leveled off and began to explore the handling. The first roll to the left was almost a surprise. The ailerons responded with very little force on the stick. The rate at which the horizon rotated across the canopy was higher than he anticipated. He checked himself, deliberately moderating his control inputs. It would have been easy, he thought, for an overenthusiastic pilot to move the stick too far and induce more roll than intended. He rolled right, then left again, this time more measured. The response remained smooth, precise, and consistent. Even at increasing speed, the controls did not seem to stiffen as much as those of some other fighters he had flown. Where certain designs demanded significant physical effort at high velocity, the Mustang stayed comparatively light. He tried a gentle bank turn, then tightened the radius. The aircraft held the turn without odd bobbing or abrupt changes in attitude. Feedback through the stick provided a sense of how much load he was pulling. There were no sudden surprises, no hint of a wing sharply losing lift without warning. Next, he checked pitch stability. Small nudges forward and back on the stick produced predictable climbs and descents. When he released pressure, the Mustang settled back into trimmed flight without oscillations. This quality, what test pilots called good manners, mattered as much as raw performance figures. It made an aircraft easier to handle in long missions and at the end of exhausting sorties. He began to vary power settings, advancing the throttle and watching how the engine and airframe reacted. At moderate power in level flight, the indicated speed crept upward steadily. There was a sense that the aircraft wanted to go faster, that it was most comfortable when not held back. At higher altitude, the engine still responded strongly, without the pronounced fall-off in performance that plagued some designs. This aligned with what he had read about the two-stage supercharging system that allowed the Merlin to maintain power as the air thinned. Climbing to over 20,000 feet, he then tested maximum continuous power. The needle on the airspeed indicator rose to numbers that confirmed, and slightly exceeded, the estimates German analysts had made based on distant observation. The Mustang's high-altitude speed was fully competitive with the frontline fighters defending the homeland. But numbers alone could not capture what Carl felt in those maneuvers. He tried a loop, beginning from a speed suited to the maneuver. As he pulled up, the aircraft tracked cleanly through the vertical. At the top, as speed bled off, there was some buffet to remind him of the approaching limits, but nothing abrupt. The nose came down through the other side of the loop, passing the horizon again with steady control. He carried out a barrel roll, blending roll, and pitch. The horizon corkscrewed around him, but the aircraft followed his inputs without hesitation. He tried a climbing turn, simulating the kind of maneuver a pilot might use to attempt to gain an energy advantage over an opponent. Throughout, the Mustang behaved in a way that inspired confidence. It did not display the tendency some fighters had to drop a wing sharply at the onset of a stall. Instead, it gave notice through vibration and control softness. For a pilot in the heat of combat, That warning could make the difference between riding the edge of performance and inadvertently entering an unrecoverable situation. He also tested lower speed handling with landing configuration extended. Gear down, flaps deployed, power set to appropriate values. In these simulations, the aircraft remained steady, forgivable, and free of vicious surprises. During all these checks, he kept a running commentary with himself, mentally framing phrases he would later put on paper. Control forces, light. Roll rate, exceptional. Stall behavior, gentle. Stability, reassuring. Engine, strong, but responsive to careful management rather than abuse. In an hour of flying, he learned more about the Mustang than any intelligence report could have told him. When he brought it back to the test facility and rolled to a stop in front of the hangar, ground crews watched his expression closely as he opened the canopy. He shut down the engine, let the propeller wind down, then unstrapped and climbed out. Asked for his first reaction, he did not deliver a long speech. He simply said that this was an aircraft unlike most others he had flown, and that German fighter pilots facing it should not underestimate what they were dealing with. One flight could give a powerful first impression. Several flights could fill in the details. Over the next days, Carl took the Mustang back into the air multiple times, each sortie dedicated to a particular set of questions. On one flight, he focused on high-altitude behavior, climbing to the upper reaches of the aircraft's operational ceiling. There, he noted how the controls felt as the air grew thinner, how the engine maintained power, and where practical limits emerged. He logged climb rates at various altitudes, compared them mentally to those of familiar German types, and paid attention to how quickly the aircraft could change levels if needed. On another flight, he evaluated dive performance. Starting from altitude, he eased the nose down, allowing speed to build gradually. The airframe held firm, without alarming vibrations or control reversal issues. The controls grew heavier with speed, as physics demanded, but remained within manageable ranges. He recorded maximum speeds reached and the behavior of the aircraft as it pulled out of the dive, noting both the structural soundness and the stress on the pilot. He also conducted fuel consumption tests. By managing power and mixture settings at various altitudes, flying steady legs, and comparing fuel used to distance covered, he could estimate realistic operational range. These numbers, more than almost anything else, explained why Mustang formations could accompany bomber streams deep into German airspace and still maneuver aggressively over targets. In his written report, he devoted entire sections to the comparison between the Mustang and the latest German fighters. He did not indulge in flattery. His task required precision. He listed where domestic designs held advantages, armament power, perhaps certain aspects of climb at specific altitudes, and where the American fighter excelled. He concluded that only the very newest variants of Germany's own leading fighters could match the Mustang in most performance categories, and even then, the difference was not clearly in their favor. When range and endurance were added to the equation, the balance tipped decisively toward the American design. He also noted subtler points. The Mustang's handling near the stall was, in his estimation, more forgiving than that of some German fighters, which could transition into spins or abrupt attitude changes if mishandled at the edge. The P-51's control harmony made it less likely that a pilot would inadvertently overstress a particular axis while in a demanding maneuver. He did identify weaknesses. The liquid-cooled engine required careful oversight. Damage to the cooling system could lead to quick loss of power. Certain fuel configurations, particularly when the fuselage tank was full, affected stability if the aircraft was maneuvered too aggressively without first adjusting the fuel load. These quirks, if understood, could be exploited tactically or at least noted in defensive preparations. Once his detailed report was typed, annotated, and sent to command levels, it did not remain confined to a filing cabinet. Copies were forwarded to fighter units defending the homeland, to training establishments, and to staff officers tasked with updating tactical guidance. Facts carried a simple message. The Mustang was not just another enemy fighter. It combined qualities that, together, made it something that could not be treated lightly. Soon after, another organization stepped in to turn that technical understanding into something more tangible for pilots at the front. On airfields scattered across Germany, fighter pilots gathered in briefing rooms where maps, charts, and silhouettes of aircraft hung on the walls. These men had already encountered the new American escort fighter in combat. They had seen its outlines flashing past their canopies, felt the pressure of its presence during interception missions. But much of what they knew about it came from hurried glimpses and stories swapped in ready rooms. Now, a traveling unit arrived, bringing with it actual machines bearing unfamiliar markings. This group, informally nicknamed a circus by those who interacted with it, was tasked with demonstrating captured Allied aircraft to German pilots. The idea was simple. If crews could walk around, sit in, and watch these opponents flown in controlled mock encounters, they would be better prepared to face them in real engagements. On the day the Mustang appeared at one such base, it taxied in with bright identification paint and large German crosses. Seeing a shape they associated with adversaries rolling to a stop among their own aircraft was an odd experience for the assembly of frontline pilots. Before any demonstration flights, an officer from the visiting unit addressed them. He spoke calmly, but the content of his remarks cut against some of the messages pilots had grown used to hearing. The narrative that German fighters were inherently superior to foreign types had been powerful in earlier years. Yet the recent months had provided enough sobering evidence to force a more nuanced description. The officer explained, in measured terms, that the Mustang they would see was not to be underestimated. He summarized key performance characteristics: speed at various altitudes, turning ability, acceleration, endurance. He highlighted that, in some respects, German fighters still held advantages, especially in firepower, but that relying solely on past assumptions about Allied aircraft could be hazardous. The pilots listened with varying degrees of skepticism, curiosity, and acceptance. Those who had already tangled with Mustangs probably found the statements more believable. Others held on to older comparisons, recalling earlier American types that had clear shortcomings. After the talk, they walked out to the line. There, the captured P-51 stood beside a Messerschmitt and a Focke-Wulf. Pilots took turns climbing into the foreign cockpit, feeling the stick, finding the throttle, testing how the canopy moved. One could almost see them mentally transferring this experience to future scenarios, imagining what it would be like to sit in pursuit or to be pursued by such a machine. Then came the practical demonstration. 3 aircraft took off: the 2 German fighters, flown by experienced squadron pilots, and the Mustang, flown by a test pilot from the visiting unit familiar with its behavior. At altitude above the field, they began a staged set of maneuvers, simulating a series of engagements. On the ground, the watching pilots craned their necks and shaded their eyes. Against the sky, it could be difficult to follow exactly which aircraft was doing what, but patterns emerged. In sustained turns, the Mustang stayed stubbornly with the Messerschmitt, not dropping away as some had expected. When rapid rolls were initiated, the long-winged foreign fighter matched and sometimes exceeded the Focke-Wulf's agility in that axis. In level acceleration, the captured machine did not fall behind. In climbs and dives, it held its own. After landing, there were fewer jokes and more quiet conversations. The visual proof had reinforced what reports and briefings could only suggest. They were facing an opponent that could not be dismissed as slow, clumsy, or easily outmaneuvered. Its range, though not immediately visible in such demonstrations, meant that it could be present over distant targets long after shorter-legged escorts would have had to turn back. For the pilots who would soon climb into their own cockpits and head back into contested skies, this realization was both valuable and sobering. They now knew that if a Mustang chose to stay with them, it likely could. If it wanted to break off and re-engage later, it had the performance and endurance to do so. And if they tried to disengage and head for home, there was no guarantee it would not follow them all the way back to the edges of their own airfields. While test pilots and demonstration teams were shaping tactical understanding, another, slower process was unfolding behind the scenes: the recognition of how industrial capacity and training pipelines intersected with the performance of machines like the Mustang. In the early years of the conflict, German fighter units had enjoyed a combination of advanced aircraft and extensively trained personnel. Pilots accumulated many hours in the air before facing hostile fire. Their aircraft, at the time, represented cutting-edge designs, and their early successes reinforced the belief that this combination could carry them through. But as the war stretched into its later phases, pressures on resources grew. Allied bombing campaigns targeted industrial centers, fuel production sites, and transportation networks. Replacing lost aircraft remained possible, thanks to adjusted production strategies and dispersed factories. Replacing experienced pilots proved harder. Training programs were compressed to meet the demand for new aircrew. Where once pilots might have logged substantial hours before joining combat units, now they often arrived with significantly less time in the air. Simultaneously, they faced opponents flying increasingly refined aircraft, supported by robust logistical systems. On the other side, American training infrastructure ramped up rapidly. Airfields across the United States turned out pilots who, by the time they reached Europe, had undergone structured programs with standardized curricula. Their aircraft, Mustangs included, rolled off production lines in large numbers, benefiting from consistent manufacturing processes. This mismatch began to show up in after-action reports. Encounters in which one or two seasoned German pilots could challenge larger formations became rarer, as those individuals were gradually lost from the roster. The newcomers, though often motivated, lacked the extra margin of experience that might have compensated for technical disadvantages. When such pilots faced Mustangs, they were up against aircraft whose strengths were tailored to exploit any lapse in judgment. A Mustang pilot with solid training and a reliable machine could use superior speed, climb, or dive performance to choose when and where to engage. The aircraft's range allowed him to patrol wider areas and remain on station longer, increasing the chances of catching opponents at vulnerable moments, during takeoff, climb, or landing patterns. Intelligence units, interested in understanding how their air arm was perceived, later collected testimonies from captured personnel. These interviews, compiled into reports for internal use, presented a clear picture. When German pilots compared Allied fighters, they frequently singled out the Mustang as particularly formidable. They spoke of its ability to appear seemingly out of nowhere at high altitude, of its persistence in following them during attempts to disengage, and of its combination of agility and stability. Some expressed a cautious respect, acknowledging that engaging such a fighter on unfavorable terms was unwise. Only those with significant experience felt comfortable testing its limits in turning engagements, and even then they recognized the risks. By the time these perspectives were catalogued, much of the broader outcome had already been decided. Air superiority had shifted. Yet these documents serve as a kind of mirror, reflecting how the opposing side had come to view the very aircraft that engineers like Karl had dissected and evaluated at the test center. For him, the Mustang had been an engineering challenge and an intriguing flying experience. For frontline pilots, it was a constant presence in the sky, an adversary that seemed difficult to escape once it had locked onto them. The gap between those two viewpoints, technical appreciation and operational reality, was bridged by a third story, that of how the Mustang came to exist in the first place. Years before Thomas Fraser took off in Jerry, and before Carl Werner walked around the captured machine on the test center apron, a different kind of race had been underway in offices and hangars across the Atlantic. At the beginning, the Mustang had not even been intended for American use. A British purchasing mission, looking for additional fighter production capacity in North America, approached an American manufacturer with a request. Could they build an existing design under license to expand output? The company, instead of simply agreeing, proposed something bolder, designing a new aircraft tailored to the requirements. Time was short. The conflict in Europe was intensifying, and the demand for modern fighters was urgent. Under these pressures, engineers worked at remarkable speed. From contract signing to first prototype flight, only a few months passed. The initial version of this new fighter, what would eventually evolve into the P-51, flew in 1940. The early variants had clear strengths. Their aerodynamics were efficient. At lower altitudes, they were fast and handled well. But they carried an engine whose supercharging system limited performance at the heights where large-scale air operations over Europe usually took place. Above a certain level, power fell off, and with it, speed. As a result, these first Mustangs found roles in areas where low-altitude performance mattered more: reconnaissance, ground attack, and theaters where engagements occurred closer to the surface. The decisive change came when someone asked a simple, transformative question: what if this well-designed airframe were combined with a different engine, one whose supercharger allowed it to thrive at high altitudes? Test installations of a new power plant with a more advanced supercharging arrangement produced impressive results. Suddenly, the same airframe that had once struggled in thin air could now reach speeds and heights that rivaled or surpassed the best existing fighters. Observers who watched these trials recognized the implications. Reports crossed desks, emphasizing that this combination, already flying in prototype form, matched exactly the kind of escort fighter needed to accompany bombers deep into enemy territory. The path from trial aircraft to full-scale production moved quickly. Licensing agreements for engine manufacture were activated. Factories tooled up. A new designation, P-51B, marked the model that married the refined airframe to the powerful engine. By late 1943, these machines began arriving in Europe. Their impact was not immediate in a single dramatic battle, but cumulative. As more units converted to the Mustang, bombing raids that had previously suffered heavy losses at long range began to see those numbers decrease. Escort fighters were no longer forced to turn back at some arbitrary line on the map, leaving the bomber formations to fend for themselves. Later improvements enhanced this core design further. A modified canopy offered improved visibility in all directions, important not just for dogfighting but for overall situational awareness. Additional armament options and fuel capacity adjustments expanded the fighter's versatility. Each of these developments rested on decisions made in design offices and factory floors long before the Mustang appeared above Berlin or Munich. The test flight Karl conducted at the German facility, years later, was in some sense an outside review of choices made by engineers he would never meet. What impressed him was not only the individual technical features, the wing profile, the cooling system, the supercharged engine, but the way they combined into a coherent whole. He could see that the Mustang had not been built as a specialist for one narrow task. It was conceived as a machine that could travel far, fly high, fight effectively, and be maintained and produced in quantity. That combination, more than any single performance figure, made it so consequential. When the conflict ended and people began to look back and ask why certain machines had mattered so much, the Mustang often appeared near the top of the list. Figures were cited, numbers of missions flown, opponents brought down, bomber losses reduced. Statements from leaders who had watched the air war shift also entered the historical record. Some spoke of the moment they saw long-range fighters accompanying bombers over cities once considered too distant for escorted raids and understood that the strategic balance had turned. In one post-war discussion, Karl was asked not about German prototypes or secret projects, but about the foreign aircraft he had tested. The questioner was clearly especially interested in the P-51. Karl answered with the same reserve he had shown in his reports. He pointed out that no aircraft was perfect. The Mustang had its vulnerabilities, such as its dependence on an intact cooling system and the need for careful fuel management. But he emphasized the overall picture: an agile yet stable fighter with excellent range, strong performance at altitude, and a layout that supported pilot effectiveness. He explained that, in his view, what made it especially noteworthy was how well it translated technical advantages into practical capabilities. A pilot did not have to fight the aircraft to extract its best. Instead, the machine worked with him, allowing him to focus more on the tactical situation and less on handling quirks. On the other side of the ocean, Thomas Fraser resumed his life after being released from captivity. For a long time, he knew only that the aircraft he had reluctantly left in a French field had been recorded as lost due to mechanical issues during a crucial day of the war. The personal cost of that loss, in his mind, was the inability to continue his mission in support of the landings. Only later, through research that connected scattered German documents with Allied records, did he learn the rest of the story. His Mustang had not simply been abandoned and forgotten. It had been recovered, repaired, flown by one of Germany's most experienced test pilots, and used as a key reference in understanding the very aircraft that was reshaping the skies. It had appeared at airfields in unfamiliar colors, teaching his former opponents to respect the design and to adjust their tactics. In a sense, the aircraft continued to contribute to the war effort, albeit in a way he could never have anticipated. The phrase sometimes attributed to the German side, that the Mustang was so capable it felt as if it almost could not be brought down, was not a literal statement of invincibility. Machines could always be damaged, pilots always made mistakes, and circumstances could turn against even the best designed equipment. Rather, it reflected a recognition that, from their vantage point, this particular fighter left very little room for error. If a German pilot misjudged energy, picked the wrong moment to turn, or assumed he could outrun an opponent, the Mustang often punished that assumption. If he tried to disengage and rely on shorter range to escape, he might find the pursuing fighter still behind him long after he expected it to peel away. From the perspective of engineers and planners, the Mustang represented something broader, the point where aerodynamic insight, engine technology, manufacturing capacity, and training systems all intersected in one platform at the right moment. From the perspective of those who flew against it or alongside it, it was simply the aircraft that seemed always to be there, high above, over distant targets, guiding bombers home, or appearing suddenly to intervene in a turning fight. When a German test pilot completed his flights in the captured P-51 and filed his report, he was not paying his enemy a compliment for politeness. He was acknowledging a reality that pilots on both sides already sensed in their own ways. The Mustang was not just another entry in a catalogue of wartime designs. It was a machine that, once refined and deployed in numbers, made certain older assumptions obsolete. And somewhere, in the overlapping stories of a forced landing in a French field, a meticulous series of test flights over a German airfield, and the long lines of contrails stretching over Central Europe, those assumptions quietly gave way to a new understanding of what air power could look like.